Hello. So today we'll be solving IBDP Physics May 2025 paper 1B time zone 1. So here is the first question, and it says a student is analyzing a sample of water. To determine its density, the student measures the volume with the measuring cylinder and the mass with an electronic balance. Identify one way to ensure that the volume is read accurately. So the volume is being read using the measuring cylinder. So to answer this question, you can write any one precaution we do while we use measuring cylinder. So first of those could be avoid parallax error. And how can you do that? By labeling your eyes with the reading. So you can say eyes leveled with the reading. Okay, and don't write outside the box because it doesn't get marked. Please make sure that you're writing inside the box. Or you can read the bottom of the meniscus, right? Read the bottom of the meniscus. Or else the third point could be, you can say that you are putting the measuring cylinder on a horizontal surface, so the cylinder is vertical. Okay, like any of the precaution you can write and you get 1 mark from it. Okay, cool. Now talking about the B part of it, B first. They're asking over here, the following data are collected. Volume is given, volume you measured, and mass is also given. They're asking the density and the absolute uncertainty in it. So density is mass over volume. That's the formula, right? The value of mass is 10.82 divided by volume is 10.6. So if I solve it, I get somewhere around 1.02. Now to find out absolute uncertainty in the density. So here, in order to get the density, you are dividing mass by volume. So whenever we get a quantity by division or multiplication, we have to add the fraction uncertainty in order to get the uncertainty in the desired quantity. So delta rho by rho, which is the fractional uncertainty in rho, should be equal to the fractional uncertainty in m plus the fractional uncertainty in v. Now I'm going to put the values, and only delta rho is missing, which they are asking. So I'm going to do that. So delta rho over, what's the value of rho? We have just calculated 1.02 equals delta m is given 0.01 over m is 10.82 plus delta v is given 0.2 over volume is 10.6. So if I solve it, I get somewhere around 0.02. Please again do not write outside the box. Okay, so 0.02 is the absolute uncertainty in it. So here the value we got in gram per centimeter cube. Okay, now in the second part they are asking state your answer in kg per meter cube. So we have got 1.02 gram per 1 centimeter cube, right? I can write this. So I have to convert gram to kg and centimeter cube to meter cube. So in order to convert gram to kg, we have to divide it by 1000, right? Divided by, if I have to convert 1 centimeter cube to meter cube, I have to divide 1 by 100 into 100 into 100, right? Centimeter cube to meter cube is, you have to divide by 100 into 100 into 100. So if I solve it, then I get 1.02 times 1000, which is nothing but 1020. But they are saying with correct precision, so we have to write the uncertainty also with that, the 1020, and the uncertainty was 0.02, and that was in gram per centimeter cube. Now to convert it into kg per centimeter cube, I'm going to multiply this also by 1000. Okay, or I'll repeat the same procedure with it. So ultimately it is 0.02 times 1000, so we get 20. This is in now kg per meter cube. Okay, now the last part of the question says when the density was measured, the sample was at 35 degrees Celsius. So this density we are getting at 35 degrees Celsius. The student has a graph that shows the variation with temperature of the density of pure water. Suggest whether the water sample can be considered pure. Now how to know if it is pure or not? So you have to see according to the graph what is the density, the value of density at 35. So 35 is around somewhere here, right? So if I look at the value, it is around 990 and 1 2 3 4 5 5 boxes is a difference of 10, so one box will be a difference of 2, and there are 2 boxes above 990, so it reads 994, right? So the value of density, it reads at 994. The acceptable values are plus minus 1. You can write 993 or 995 is also acceptable. Okay, and this is at a temperature 35 degrees Celsius. This is what the graph reads. Now when you calculated it, what did you get? You got 1020 plus minus 20 kg per meter cube, right? This is also in kg per meter cube, but the calculated value was how much? 1020 plus minus 20, right? Kg per meter cube, and this is also kg per meter cube. So do you think they are nowhere in the range, right? So the value that you are reading, you are getting experimentally, is out of the range, outside the range of 1020 plus minus 20. It is nowhere between 1000 to 1040, right? So we can say the sample is not pure. So that's all. This was the question number 1, and if you were able to do so, you got 2 plus 1 3 plus 2 5 and 6 marks. Okay, I hope you understood whatever we did here. See you in the next video. Bye bye.